Yes, good afternoon. Good afternoon, students. Welcome to the 19th lecture of Industrial Applications of VCR and Problems. So today in this class, we'll discuss about the topic of VCR applications where we are using in various industries and other purposes. In this session, we will deal the industrial applications as well as the problems related to the vapor compression cycle, which has been divided into four types, right? So in the last class we have seen the introduction and difference between the window AC and split AC, floor mounted AC and cassette type of AC by using vapor compression refrigeration cycle. Now we see where these air conditioning systems are used commercially in the society, right? Later we see the cycle variations, the vapor compression cycle variations and their analysis, and also few problems related to the topic, right? Yes, now we see the industrial applications. This type of variable compression refrigeration cycle are used almost all sectors, right? So air conditioning, refrigerator, ACs, television, vehicles, all this has been become an important part of human society. Everyday environment we live in is in verge of pollution overtake. It's important to us we breathe good air conditioned air. Air conditioned as the following applications. So recently if you see due to this pandemic COVID situation, many of the companies are started manufacturing the oxygen plant. So oxygen neutralizer or oxygen machine, right? So which is an important part of the human life. At the same time, the air conditions are also has been become an important part of the human life. Without air condition, we cannot survive in summer. That is a thing came into everybody's mind, right? And also the applications where we are using this air conditioner are very versatile. And also the types of air conditions, that is window AC, split AC, uh, wall mounted AC, right? Floor mounted AC, total air conditioned plant like this. So many applications have been emerged. Let's see some of the applications of this industrial applications, right? So if you see the air conditioning definition, the air for the natural and comfortable atmosphere within the living area, particularly in home or office. In home or office, we require generally a natural air. So in olden days, because of non-urbanization and also mechanical life and also mechanization and the concrete jungle, so we are having number of plants and trees around the houses. At the time, we doesn't require any artificially natural air by making use of these machines. So we have inhaled, our ancestors have been inhaled by using natural air. So it's some design and it's some customization. But this air condition has given a change in the life. Okay, filtering air for dust particles. So generally, uh, in the air. So without in the generally in the air, so with our naked eyes we cannot see some other pollutants along with the air. So generally if you smell something or if you do something, so whatever the objects you're doing, automatically the air is inhaled through the nostrils. So whenever we breathe air, automatically the dust particles in the air also go inside the your nose. That's why we have the nose hair at the entrance of the nose in order to accumulate the dust particles. In the same way, the air conditioning systems are also having such type of filtration system for collecting the dust particles, insects, other materials and other microorganism living in the air. Next point. Employed in large supercomputer halls to small desktop rooms for keeping them. So with the evolution of these computers, so generally computers need cold environment in order to work properly. So that's why whenever you're using computers at your domestic purpose, one system or other laptop, so generally we use normal air conditioning system in our house. So whenever there is a work or whenever there is a need for high-end computer servers, a room big size, then automatically we have to go for the commercialization of this system, right? Next, fourth point, constant temperature is to be maintained. So what type of temperature? Constant temperature should be maintained in tool room, as you know metal are not so trusted with changing temperature for their dimensions, right? Constant temperature should be maintained in any room, right? As you know the metal doesn't trusted with any changing temperature for their dimensions. For example, uh, if you keep any metal objects inside the fridge, then rather than plastic, etc., first the metal items will get cooled than plastic. Or in your AC rooms, whenever you are having um, household materials apart from your cot, your bureau made up of metal, other shelves made up of metal, your sugar rack made up of metal, everything. So whenever you are choosing whenever you are choosing the other materials apart from the iron, automatically the cooling effect will be reduced. So in a AC room, first the metals will take the cooling effect than that of the humans and plastic. Air conditioning helps to shop owners. Air conditioning helps the shop owners for a good sale, or maybe that is why we hang out in malls more than often in college days. So what are you saying? So whenever in order to attract the customers or in order to fulfill in order to fulfill the needs of the customers, the shop owners or the companies or organizations are doing centralized AC or keeping AC inside the shop so that the sales will increase, so that the productivity will increase, so that the goodwill will increase. So that type of idea or term, not that type of things also can be done whenever you have been using the air condition system. Next, air conditioner keeps the boss cool in office. Just imagine what would you like a sweetie red boss, right? And also whatever the works happening outside. For example, being a mechanical or civil engineer, whenever you got a job on a job site, on site, on road or somewhere else. So whenever you are doing or maintaining the material or the company, so whenever you get the high heat to your body, then automatically, so whenever you enters into the AC room, it will become cool. It will become cool, and therefore satisfaction will get prevails. That is the third point in the next point in this industrial applications. Next, did I say that some of the air conditioner breed can maintain the humidity level. So some of the air conditioners like Samsung or Blue Star or so something, some of the air conditioners are also maintaining the humidity level. How much amount of humidity is there in the room? How much should be there? How much should evaluate? So this type of system will be maintained. Next, air conditioner can keep your food fresh for a little longer, sometimes even for 2 years in a cold rooms. So what is the other advantage? So the air conditioner is also useful for not to spoil the perishable items. The perishable item means which doesn't give longer life. That's are called. Next, air conditioner is used in operation theaters so that the patients could get well soon other than getting his wound septic due to the microorganisms present in the air, which has stated in condition without AC. So what the ninth point is saying? The ninth point is saying that in hospital field also, medical and hospital field also, the air conditioning usage is very much. So not only instead of in the owner's room, not only instead of the owner's or the hospital's room. So this has been done in the normal beds and operation theaters also. So this usage of air condition will reduce the fatigue. Will reduce the fatigue. Next, air conditioning keeps your office toilet smell free at its 80%, 85% fresh air for every intake of air. So what it is saying? So air conditioning keeps office toilet smell free from 80%, right? Whatever the dust particles or whatever the smell coming from this thing, it can be removed. Next, did I mention that AC are used in car and other such vehicles for the comfort of rider aeroplane too? So obviously, four wheelers, your four wheelers, majority of the four wheelers and buses, trucks, aeroplanes, ships, all are using this type of second grade. So doesn't require this type of system. Testing rooms are generally air conditioned. Testing rooms means, for example, if you take your engineering laboratories, so majority of laboratories names heat ekunda, so it should not get heated up, right? Next, testing of rooms are generally require air condition. So what is the meaning of this testing of rooms? Testing of rooms means, for example, in your laboratory, you are having more than 10 labs in VTech level. Some testing rooms definitely require this air condition, right? So whenever you are doing any lathe operation or whenever you are doing any grinding or any beating operation, this type of system is not good. So the political ownership means once the things what you have kept a lot, then based on that you have to realize first to go to the that corner east and start way, right? Next, parking lot needs air conditioning. This doesn't mean that to cool the air, but just to circulate the air. A fan, especially exhaust fan, will do the work. So generally, the HVAC is very very important in the subject point of view, right? So here it is saying the parking of cars require AC and also ventilation. So whenever the cars are going deeper and deeper, just like 5 floors, 8 floors, 10 floors, then automatically the oxygen levels are maximum reduced. In such way, this will help a lot so that doesn't mean to cool but just to circulate the air. Air conditioning of stir well. So air conditioner will do all the processes in 100% efficiency. There will no be any still curriculum. Next, air conditioning in airports and bus stands for the comfort of passengers. Obviously, nowadays we are seeing AC bus, AC cars, AC lorries, AC etc. 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 Why we are using this type of AC customized and also for industry means the simple thing is satisfaction. The simple thing is a satisfaction. So that's why nowadays all the buildings, buses, cars, whatever the place the people are going in a crowd, obviously you have to keep the washing machine. So whenever you are not keeping the washing machine, automatically it will be a problem. So that's why uh, this type of systems are used everywhere else at every place. So these are some of the industrial applications can be done with this hang and dynamic fashion, right? Air conditioning in airports and bus stands for the comfort of the passengers. Next, we'll see the problems. Hope you understood. Now we'll see the problems. Next we'll go to the problems. Next we'll deal problems. The following are the data. The following or the data refers to the 20 tons ice plant using ammonia as a refrigerant. So in this question we are using ammonia as a refrigerant and we are using how much coolant means 20 20 ton per ice plant, 20 ton plus 20 tons ice plant require ammonia. Any so depends upon the question. The temperature of water entering and leaving the condenser are 20 degrees centigrade and 27 degrees centigrade. And the temperature of brine in the evaporator is 15 degrees centigrade, 15 degrees centigrade. Before entering the expansion valve, the ammonia is to be cooled at 20 degrees. This is to be cooled at 20 degrees, and the ammonia enters the compressor dry saturated. Now calculate what? Calculate for 1 ton of refrigeration, the power expanded, the amount of cooling water in the condenser, and the coefficient of performance of the plant. Now read the question once or twice, and we have to frame the given data. So once you have started reading minimum three times, you have to frame the given data. Next, what to do. Next one, formula and doing the problems. Next, see the table. Use the properties of the given table below. So here you are having the saturation temperature is 15 degrees minus 15 degrees, that is 112.34 liquid, 114.26 vapor, that is at the enthalpy, entropy and specific heat. Enthalpy, entropy and specific heat. Next, now write the given data as per the question. So before solving the problem, you have to first listen the person what he is fetching, right? Next, this is the enthalpy, this is the entropy, this one is a specific heat, this one is a heat. Now write the given data as per question. 20 tons, the discharge Q is equals to 20 tons. Next, TW2 is equals to 20 degrees, that is equal to 3293 Kelvin. TW1 is equal to 27 degrees centigrade plus, that is 300 Kelvin. Now T2 dash is equal to T3 dash, that is equals to 25 degrees centigrade. Next, next T1 is equal to T4, that is equal to minus 15 degrees centigrade, that is the evaporator. That is T3 is equals to 20 degrees centigrade, that is equal to 20 plus 273, 293. Next HF1, HF1, this one HF1, HF1 is equals to 298, HF1 is equals to, where is it, HF1 is equals to 112.34, HFS is equals to, HFS is equals to 298.90. H1 is equal to 1426 divided by 54 divided by 54. H2 dash is equals to 1465.84 and SF1 is equals to so and so. K is equals to S beta, that is equal to 1.124 kilojoules per kg into K. That implies S1 is equal to S2 is equals to 5.59490 kilojoules per kg Kelvin. Now S2 dash is equals to 5.031 and CPL4 is equals to 4.396 and CP3 is equals to 4.606 and CP1 gamma 1 is equals to 2.303 Kelvin and E V2 is equals to 2 dash 8.85. Now start doing the procedure. Power expended by TR per TR is equals to see the TS diagram and PS diagram, right? Now see here the temperature and the entropy. Here the temperature is rising, that is at T1 258 already given, T2 298 given, so it has been had some life, right? See here T2, so we have to find T2 along with this S1 dash. Now see here S1 dash S2 dash, S2 is equals to S2 dash plus 2.3 CPV1, that implies this one log into T2 by T1. Now the value already we know this value, we know this value, we know this value, and we know that value also. So finally T2 is equals to T2 by 292 log is equals to, so by solving this one, finally we got T1 T2 value is equals to 1.2 into 298, that is equals to 84.6 Celsius, 84.6 Celsius. So if you see the diagram here, so HF3, HF3, HH1, H2, H3, T1, 2, 2, 3, 3, 4. You are getting the bonds like this, right? Next. Now the enthalpy point at 2 is equals to H2 is equals to H2 dash plus CPV2 T2 minus T2 dash. So applying directly 146 to 847, right? 146.84 plus CPV2 minus T2 minus T2 dash, that is equal to 60. Right, next. And the enthalpy of liquid refrigerant at point 3 H beta is equals to HF3 dash minus CPV into degree of uncooling. Therefore, H3 dash minus CP is equals to T2 minus T1. Right, next. H beta is equals to HF3 dash minus CP3 into degree of understanding. Therefore, 298.9 minus 4.606 half T3 dash value minus T3 is equals to, so they came down with next amount of cooling within the condenser. So let M1 is a mass. We know that the refrigerant in the condenser is equals to MR of H2 minus HF3. So we know the value MR, and H2 value 1633 minus 275.87. So upon substituting this one, we got CW is equal to 4.187. Therefore, the heat taken by the water in the condenser is equal to MW into CW TW1 minus TW2. So upon substituting the values MW into 4.187, 300 minus 293, that is equals to 293, 29.3 MW kilojoules per minute, right? Therefore, the heat by the refrigerant in the condenser is equal to the heat taken by the water. Thereby, applying the equation 1 and 2, 29.3 M is equals to 29.3 M is equal to 4953.6. Therefore, MW value is equals to 169 kg per minute. 169 kg per minute. Next, we'll see the next problem. Next. Next. Let's see the next one. Yes. A vapor compression refrigerator. A vapor compressor refrigerator works between the pressure of 4.93 bar and 1.86 bar. We know that 1 2 3 4, and that 1 4 is on one line, 2 3 is on one line. So the VCR works between the pressure 4.93 and 1.986 bar. The vapor is superheated at the end of the compression, its temperature being 25 degrees centigrade. The liquid is cooled at 9 degrees centigrade before throttling. So when it is getting before throttling, it is to be cooled at 9.9 degree centigrade. The vapor is 95 degrees dry before compression. On to the vapor is 95 degrees dry before compression. Using the data given below, calculate the coefficient of performance and refrigerant effect per kg of the working substance circulated. See the table chart given. What is the pressure given? The pressure bar is equal to 1.86, 4.93. Next, what is the next given in the question? Minus 15 degrees centigrade. There is a minus 15 degrees centigrade, and saturation temperature is 14.45. Then the total heat in liquid is 21.67 and 49.07. Now the latent heat is 161.41 and 147.80. Now what is the specific heat at a constant pressure for this superheated vapor is 0.645, and for liquid is 0.963. So these are the pressures for superheated vapor. Next, so from the given question, write the given data. Here P2 P3, so ఈ రెండు ఇది P1 P2, sorry, this is P1 P4 and P2 P3. So whenever you are using this one, blindly draw the graph and only change the value so that you can draw something before examination. Next, here P2 is equal to P3. The top things are same, that is 4.9 bar, 4.93 into 10 to the power of 5 Newton. Next, P1 is equal to P4, that is equal to 1.86 bar, and T2 is equal to temperature 25 degrees, that is plus, and T3 is equals to 9 degrees, that is plus. And what it is saying, the vapor is 95% dry before the refrigerating effect. So therefore x is equals to x1 is equals to 95 degrees, and T3 dash is equal to T2, that is equal to 14.45. This one 14.45, 14.45, that is equal to 14.45 plus 273. Now T1, we know T1 is equal to T4 is equal to minus 15 degrees centigrade, and HF1 is equals to 21.67, and HF3, that is equal to HF2 is equal to 49.07. Now HFS1 is equals to 161.41, and HF2 is equals to 147.8, and Cp is equals to 0.645 kilojoules per Kelvin, right? So this is a working given information for this vapor compression refrigeration cycle. Now first draw the graph, first write the given data as usual, right? Next draw the graph pH and TS diagrams, therefore the temperature and the enthalpy. Now here the temperature T1 is equal to T4 is equal to 258, that is given in the question. Next T3 T4 is equals to 287 282. Got it? Therefore P1 P4 and P2 P3, this one is 282. Now see the pressure and enthalpy. Now next, coefficient of performance. Next thing is a coefficient of performance. We know that the enthalpy at point 1, H1 is equals to HF1 plus X1 HF G1, that is equals to, apply the values, HF1 plus X1 plus HF1 plus X1 into 161.41, you are getting 175 kilojoules per kg. Similarly at point 2, H2 is equals to H2 dash plus CPV plus degree of superheat, that is equal to HF2 dash plus HFG2 dash plus CPV T2 minus T2 dash. So directly we are getting the answer this type. Next, the enthalpy at the point 3, ఇక్కడ point 1 అయిపోయింది, next point 2 is over, now point at 3. Therefore HF3 is equals to HF3 dash minus CP T into degree of freedom. Therefore HF3 is equals to here HF3 minus CPV is equal to HF3 minus CPV T2 dash minus T3 dash, that is equals to 49.07 minus CP L and T3 dash minus T3, that is equal to 43.82. Therefore, coefficient of performance is equals to H1 minus HF3 minus H2 minus H1. So applying the formulas directly, HF2 H45.22, next H1 is equals to 175. So upon solving this one, we are getting this answer, that is a coefficient of performance. Next, refrigerating effect per kg of working substance. Here the refrigerating effect is equal to H1 minus HF3. H1 minus HF3, that is equal to 175 minus 43.82, that is 131.18 kilojoules per kg, right? So I think the time is up. So here the time is also completed. I stop the class here and we'll discuss the class tomorrow, right? So I'll stop the class at this point, or we'll see the second question. Okay, so we'll start this problem. A simple ammonia compression system, here the refrigerant is ammonia, compression system operates with a capacity of 150 tons. The condensation temperature in the condenser is 35 degrees centigrade. The evaporation temperature in the brine cooler is minus 25. The ammonia leaves the evaporator and enters the compressor at minus 8 degrees centigrade. Ammonia enters the expansion wall at 30 degrees centigrade. Wire diagram through the compressor walls. Now, what is the given data? Suction operates with a capacity of 150 tons. Right, the operation is 150 tons. The suction is 0.118 bar, the discharge is 0.23 bar, compression index is 1.22, and volumetric efficiency is 0.25. Calculate the power heat transfer to cylinder with the water jacket, pistons replacement, and power transmission and 5 off. Right, now based upon that, what you have to find? The power you have to find, right? Next, calculate the power heat transferred to the cylinder and piston displacement, the heat transfer in a condenser, and coefficient of performance. So write the given data as per the question. G is equals to 150 tons. 150 tons. 150 tons. T2 is equal to T1 is equals to T3 is equal to 35 tons. That is equal to 35 plus 2 is 73. That is equal to 308. Right? Now draw the pH diagram and pH diagram respectively. From the pH diagram, the pressure corresponding to the evaporator temperature is P1 is equals to P1 double dash, that is equal to P4, that is equal to 1.15. Therefore, at point 1, P1 dash is equals to 1.518 minus 0.118, that is equal to value. Now, by taking the pressure 35 degrees, we can see 35 degrees. 35 degrees. Therefore, the yes. Next, the pressure corresponding to condensation temperature is 35 degrees. That is equal to 13.5 bar. At the pressure point 2, P2 dash is equal to 13.5 plus 0.23, that is equals to 13.77 10 to the power of 5. Next, So if you see the TS diagram and PV diagram as usual, what you have seen now, the H1 is equals to H1 dash, that is equal to 1004 watt as it is in the table. Specific volume at point 1 is equals to V1 dash is equals to zero point 0.8 meter cube. The temperature at point 1 is equals to T1 dash is equals to, that is 9 degrees, that is equals to minus 9 plus 273. That V2 is equal to specific volume at point 2. Therefore, by using the normal formula, P1 is equals to P2 V2. Therefore, we require V2 dash, that is equal to V1 of P1 dash by P2 dash divided by 1 to 2. That implies applying the values directly in that, we are getting the V2 dash is equals to 0.123. Now take at the point 2 on the pH diagram and start doing at pressure point 2 at 2 dash. H2 is equals to H2 dash, that is equal to 1620. Now the temperature at point 2 is equals to, right? Now see the enthalpy of ammonia at the point 2, H2 is equals to H2 dash, that is equal to 1620. The temperature at point 2 is equals to 90 degrees. The liquid ammonia should complete. The liquid ammonia should vaporize at point 2 dash. So we got the value T2 dash is equal to 90 degrees centigrade and HF3 is equal to 320 degrees centigrade. Now calculate the power. We know that power RE is equals to H1 minus HF3. Therefore, the mass flow we have to find out. MR is equals to 31,500 divided by RE divided by 1120. That is equal to 28.12. Therefore, the compressor per minute, that is equals to MR into N of N minus 1, P2 V2 minus P1 V1. So substituting the values, 28.12 into 1.22 by 1.22 minus 1, P2 V2 minus P1 V1. So upon substituting all the values, we are getting 8,900. Therefore, the power is equals to 8,900 by 60 minutes. That is equal to 148.3 kilowatts. So with this, we'll stop the class. I have the next class 2 to 240. So we'll stop the class here. We'll continue tomorrow.